If you're just starting out in coding, you'll run into small, sneaky logic mistakes that don't crash your app, but cause weird bugs later. We've all been there. My early projects were full of them. In this video, I'll break down the 10 most common logic errors I see junior devs make with clear examples and practical tips. The goal? Help you spot these bugs, understand why they happen, and write cleaner, more reliable code. Think of this as your cheat sheet to level up fast. Let's dive in. First up, let's dive into a coding conundrum that has plagued developers for generations. It's a subtle error often lurking in the shadows of your loops and arrays, waiting to trip you up. It's the infamous off by one error. A tiny miscalculation that can lead to unexpected results and frustrating debugging sessions. This happens when your loop runs one time too many or too few, when your code iterates just a little bit beyond or falls slightly short of the intended range. Imagine processing 9 items instead of the intended 10, leaving one crucial element untouched and unprocessed. Or even worse, trying to access an array index that simply doesn't exist, venturing beyond the boundaries of your data structure. This can lead to a crash or unpredictable behavior. The culprit? Loop boundaries. The conditions that dictate when your loop starts, stops, and how it progresses. For zero-indexed arrays, which are common in many programming languages, indices go from 0 to length -1. This is a fundamental concept to grasp. If you write, you'll try to access an out-of-bounds index, causing your program to stumble and potentially crash. Always use for zero-based arrays to ensure you stay within the valid range of indices. Before running your code, take a moment to mentally trace your loop's execution. What's the first and last value of? Understanding these values is key to preventing off-by-one errors. Double-check your boundaries. Scrutinize the starting and ending points of your loops. Pay close attention to the subtle difference between less than versus less than or equal to. These seemingly small details can have a significant impact. This habit saves hours of debugging, preventing you from chasing down elusive bugs. Pay attention to your loop conditions. They are the gatekeepers of your array access. It's a small detail, but it's foundational for writing robust code that behaves as expected under all circumstances. Master this, and you'll avoid a classic pitfall, writing cleaner, more reliable code. Next, the dreaded infinite loop. This happens when your loop's exit condition is never met, usually because you forgot to update the variable in the condition. For example, a loop with no will run forever. Your app freezes, CPU spikes, and you're forced to kill the process. The fix? Always ensure your loop variable changes in a way that guarantees the loop will end. When writing a loop, immediately add the line that updates your condition variable. Think, what will make this stop? Build your exit strategy into the loop from the start. This discipline prevents program freezes and makes your code safer. Infinite loops are easy to create, but even easier to avoid with a little care. Always check your loop's exit path. Equality operators can often trip up a lot of new developers, especially those just starting their journey into the world of programming. It's a common area where mistakes can easily creep in, leading to unexpected behavior and frustrating debugging sessions. Understanding the nuances of these operators is crucial for writing robust and reliable code. This is especially true in JavaScript, a language known for its flexibility and sometimes quirky behavior when it comes to type handling. The way JavaScript handles equality can be a source of confusion if not properly understood. Let's break down the 3 different equal signs you'll encounter in JavaScript. First, we have the single equal sign, which is used for assignment. It takes the value on the right-hand side and assigns it to the variable on the left-hand side. This is a fundamental operation in programming, allowing us to store and manipulate data. Next up is the double equal sign. This operator compares values for equality but with a twist. It performs type coercion. This means that if the values being compared are of different types, JavaScript will attempt to convert them to a common type before making the comparison. Finally, we have the triple equal sign. This is the strict equality operator, and it compares both the value and the type of the operands. No type coercion is performed. The values must be identical in both value and type to be considered equal. It's crucial to remember to never use a single equal sign in a comparison. This is a common mistake that can lead to unexpected results and hard-to-find bugs. The single equal sign is strictly for assignment only. Using it in a conditional statement will assign a value rather than performing a comparison, which is almost certainly not what you intend. The double equal sign, with its type coercion, can often lead to unpredictable results and subtle bugs that are difficult to track down. This is because it automatically converts types behind the scenes, which can sometimes produce unexpected outcomes. The triple equals sign, on the other hand, is strict. It only returns true if both the value and the type of the operands match exactly. This makes it much more predictable and reliable. For example, the expression is true because JavaScript converts the string 5 inches to the number 5 before comparing. But the expression is false because the types are different, string versus number, and no type coercion is performed. Therefore, make it a habit to always use the triple equals sign for comparisons in your JavaScript code. This simple practice will eliminate a whole class of bugs that can arise from unexpected type coercion, leading to more robust and maintainable code. Only use the double equals sign in rare and very intentional cases where you specifically want type coercion to occur. By sticking to strict equality with the triple equals sign, your code will become more predictable, easier to understand, and significantly easier to debug. You'll spend less time scratching your head over unexpected behavior and more time building awesome things. So, remember this golden rule. Always be strict when comparing values in JavaScript. It's a simple rule that can save you countless headaches and make your coding experience much more enjoyable. Embrace strict equality and write better JavaScript. Uninitialized variables are a recipe for chaos. If you declare a variable but don't set an initial value, it could be, or garbage, depending on the language. This leads to confusing bugs like getting when you try to add to an undefined number. The fix is simple. Always initialize variables when you declare them. Numbers, set to 0, strings, empty string, arrays, empty array. This is defensive programming. Your code's behavior becomes predictable. No more ghosts in the machine. Make it a rule. Every variable gets a sensible default. Your future self will thank you. Don't leave variables empty-handed. Accidentally overwriting data is a silent killer. It happens when you reuse variable names for different things, or overwrite a value you still need. For example, using for both API results and a loop variable, suddenly your original data is gone. The solution? Use clear, descriptive variable names, not just limit variable scope. Declare variables only where needed using and. This prevents accidental overwrites and makes your code self-documenting. Be specific with names, strict with scope. Protect your data from friendly fire. Small changes here prevent big headaches later. Name things well and your code will thank you. Messy conditional logic is a common trap. A classic mistake, putting broad conditions first in an if-else chain, so specific cases never get checked. For example, grading logic. If you check for score 50 inches before score 90, high scores get the wrong grade. Always order your conditions from most specific to least. Deeply nested ifs are another problem. They're hard to read and debug. Simplify by combining conditions or refactoring into functions. Manually trace your logic with sample inputs to catch mistakes. If your ifs are getting too deep, it's a code smell. Flatten or rethink your logic. Clean, clear conditions make for bug-free code. Don't let your ifs become a maze. Junior devs often code for the happy path and forget edge cases. Edge cases are unusual or extreme inputs like empty arrays, null values, or very large numbers. Ignoring them leads to crashes and bugs like dividing by 0 or accessing missing elements. Always ask, what happens if the input is empty, null, or weird? Handle edge cases first, often with a guard clause at the top of your function. Example: this keeps your main logic clean and safe. Test your code's boundaries, not just the ideal scenario. Thinking about edge cases builds resilient software. Challenge your assumptions. Robust code starts here. Boolean logic and Oregon not can be surprisingly tricky. A common mistake, using and when you mean or vice versa. For example, is never true you want. De Morgan's laws can also trip you up when negating complex conditions. If your Boolean expressions get confusing, draw a quick truth table to clarify. Simplify long conditions by breaking them into clearly named variables. For example, use instead of a long compound condition. Clarity is key. If a condition is hard to read, refactor it. Boolean bugs are subtle but easy to fix with careful logic. Make your intent obvious. Clean logic, fewer bugs. Magic numbers, hard-coded values with no explanation, make code hard to read and maintain. If you see, what does 2 inches mean? The fix use named constants, like now, is clear and self-documenting. If the value changes, update it in one place. Avoid hard-coding numbers unless they're truly universal, like 0 or 1. Named constants make your code readable, maintainable, and less error-prone. Don't keep secrets in your code. Give numbers a name. Your future self will thank you. Ever feel like your code is speaking a different language? You're staring at the screen, completely lost, wondering where it all went wrong? Ignoring error messages, those cryptic lines of text that pop up when your program decides to throw a tantrum, is a huge logic mistake. It's like ignoring a flashing warning light on your car's dashboard. When your code crashes, and let's face it, it will crash, the error message and stack trace aren't just random gibberish. They tell you exactly what went wrong, often down to the specific line of code and where that line is located within your project. Think of it as a detective giving you the crucial clues to solve the mystery of your bug. Don't panic or start guessing. That's the equivalent of randomly throwing darts at a board hoping to hit the bullseye. Instead, take a deep breath and read the message carefully. Approach it like a puzzle waiting to be solved. The error type and description are pure gold. They're the key to understanding the nature of the problem. For example, a classic JavaScript error. Cannot read property name of undefined. This tells you exactly what's wrong. You're trying to access a property called name on something that doesn't exist. It's undefined. The stack trace, often a series of file names and line numbers, shows the file and line number, the exact location in your code where the error occurred. Use it, click on those links, jump to those lines of code. New workflow, embrace this process. Code crashes, stop, resist the urge to immediately start changing things. Read the error out loud, sometimes just verbalizing the problem can help clarify it in your mind. Check the first line of the stack trace, that's usually where the error originated. Go to that line, open the file, find the line number, and examine the code around it. Now you know the what and where. You know what the error is and where it's happening. Figure out the why. Why is this happening? What sequence of events led to this error? If you don't understand the message, if the error is still a mystery, search it online. Copy and paste the error message into your favorite search engine. Learning to decode errors, to understand what the computer is trying to tell you, is a programming superpower. It's what separates the seasoned developers from the frustrated beginners. Don't debug by coincidence. Don't just randomly change things until the error disappears. Let the computer help you. It's already giving you the information you need. Error messages are clues, not enemies. They are your guides in the debugging process. Use them to your advantage and you'll become a much more effective and confident programmer. That's a wrap on the 10 most common logic mistakes for junior devs. The goal isn't to never make mistakes, but to spot and fix them quickly. Keep coding, keep practicing, and your intuition will grow. Don't be afraid to break things. Learning happens there. Stay curious, keep learning, and look things up when you're stuck. Every bug you fix is progress. Share your own logic bugs in the comments. Let's learn together. Thanks for watching. See you next time.